Hello students, today let us learn about the grand unifying theory of geography, that is plate tectonics theory. So among all the theories of geomorphology, plate tectonics is one of the important theories which connects all the dots that were there in the theories that were proposed earlier. Now if you look at this particular short video here, this represents the convectional currents that were happening inside the earth, okay, because of the internal heat that was provided from the core region. The heat gets dissipated through the mantle, towards the mantle. There in the asthenosphere, what happens is that the radioactive materials that were present over there will react and it will lead to the convectional currents like this. And this theory of convectional currents was proposed by Arthur Holmes. This is a theory which is earlier to your plate tectonics. Then later, there is another geographer called Harry Hess who have propounded this theory of sea floor spreading. So, if you observe the convectional currents here, don't you think there the convectional current is diverging the plate, separating the plate into two parts? When plates which were attached together were getting diverged, the magma which is inside it is coming out, it is settling down near the crust and forming a new crust. It means the divergent plate boundary is a constructive plate boundary where a new crust is formed. Now, this is something which is observed in the mid-Atlantic region. When Harry Hess, with the help of radiometric dating, deep ocean studies and all, with paleomagnetic evidences, etc., they found that close to the sea floor, in the sea floor inside, in the middle of the sea floor, that is in the Atlantic Ocean, near the mid-Atlantic ridge, the crust age is younger compared to the crust which is close to the coastline of Africa and South America and Africa. Why do you think is the reason? The simple thing is that there is a divergence that is happening which is dividing the crust and creating a new crust. So, with the help of paleomagnetic evidences and also radiometric dating, it is clearly seen that sea floor is spreading. So, taking convectional current theory and sea floor spreading theory into consideration, plate tectonics theory was proposed. Now, just see this. This is how the sea floor spreads, means continuous divergence creating a new crust and sea floor starts spreading. So, it means a new crust is forming. Then you might get a doubt, if this was the case, why can't you have earth that is growing in size? The so called crust of the earth is conservative, right? How could that be possible? That is something which is explained by your plate tectonic theory. Now, observe the Himalayan mountain system, the greater Himalayas, the volcanic arcs that were there, earthquake affected regions, and when geographers try to map all these regions like areas where frequent earthquakes were happening, areas where there were young fold mountains and areas with more volcanic activity, they have found an interesting fact. Here the points that were blinking on the screen are the areas which are most affected by tectonic activity. Now, when they draw lines joining all those particular points, there they realize that we have the crust of the earth which is not a continuous part but separated into pieces like the puzzle pieces that you play. Now, observe this world map. You have the crust that was divided into different parts and each of those parts is having a significance. What was that? If you observe the African region, that is the African plate, it is having a continental part, that is the continental crust, and it is also having an oceanic part, that is your oceanic crust. So, as per the theory of plate tectonics, if you see, the whole earth surface is divided into certain plates, okay. So, if you observe, we have major plates that were present. Just see here the Eurasian plate, African plate, South American, North American, Indo-Australian, African, Pacific plate and Antarctic plate. So, what is plate tectonic theory? Plate tectonic theory's first argument is that the crust part of the earth is not continuous. It is divided into pieces, and each of that plate is having a continental crust and an oceanic crust, or a mixture of both. Sometimes there might be a specific oceanic crust like your Pacific plate. There will be specifically continental crust like your Eurasian plate if you see. So, plate tectonics theory further states that all the plates that you see here are having different interactions. Now, observe this area, the African plate which is having continental crust and oceanic crust, and each of these plates were having some interactions. What are those interactions? In a certain area, the plates are diverging, that means they are separating, and in another area it is converging, it means the crust is getting destroyed. And in few areas the plates are neither converging nor diverging, instead they are sliding against each other, showing the transformed nature. So, plate tectonic theory further states that the crustal part of the earth is not continuous, and there are certain interactions between those particular separated plates, and that is the divergent plates, and then convergent plates, and then transform plates. Now, if you see, there are 3 plate boundaries or 3 plate interactions, that is convergence on this side, divergence and transform, wherein the plates will slide against each other. Now, further plate tectonic theory continues to say that we have continental crust and oceanic crust. There are different interactions. For example, if you observe the divergent plate boundaries, there is continent-continent divergence. What was the example for that? The example for that is your East African Rift Valley. You observe the Africa region, okay, just towards the eastern side of it, close to your Mount Kilimanjaro, you have East African Rift Valley. It means the continental part is getting diverged there. Why it is diverging? Simple, there is convectional current inside it. And then you have ocean-ocean divergence as well. Okay. For example, the Atlantic Ocean that I have shown you with respect to sea floor spreading. Then when it comes to convergence, okay, you have continent-continent convergence, just like your Himalayan mountain belt, okay. In the Indian subcontinent, the Indian plate is converging with the Eurasian plate, showing continent-continent convergence. And then there are certain instances where ocean-ocean convergence also present. It means what? 2 oceanic plates converging to form a trench kind of situation. So, if you see, this is how the convergence takes place, wherein one plate subducts and it will be destroyed. Alright. Now, if you observe, apart from continent-continent convergence and ocean-ocean convergence, we have ocean-continent convergence as well, okay, wherein there will be an oceanic plate which will be subducted, or in case if you are seeing convergence activity, important point that you need to remember here is that whenever 2 plates converge, the heaviest plate will subduct. Oceanic crust being the heaviest one will subduct. Now, you might get a doubt, we have ocean-ocean convergence, continent-continent convergence and ocean-continent convergence, but please remember, when it comes to divergence, we have only continent-continent divergence and ocean-ocean divergence. Okay. And if you ask me why continent-ocean divergence is not there, it is simple. Ocean, continent are of different densities, and it is quite impossible to have divergence there. And by today, if you see, there is no evidence of ocean-continent divergence. We do not know how geography turns us in future. Anyway, now this is about convergence and divergence. Then, as I told you, we have another kind of plate boundary, which is a transform plate boundary. So, wherein the plates will slide against each other. So, finally, what plate tectonic theory says is that the reason behind the formation of young fold mountains like Himalayas, or the volcanic eruptions, or the earthquakes, or various first degree landforms is your plate tectonic activity. And these plates are having convergence, divergence and transform that is continuously shaping the earth. In your continental drift theory, there was a question that was unanswered, that is the reason behind the drift of the continents. We all knew, right? Continents are continuously moving. Even India plate is still moving 5 centimeters per year towards northern belt, and that's what is the reason for the highest altitude of Himalayas, and we say they are still growing. The reason behind it, or the reason behind the continental movement, is actually given by your plate tectonic theory. And for optional purpose or for the general studies purpose, it is quite an important task to remember plate tectonic theory using examples. Now, if you look at this particular map, in order to easily remember the plate tectonic theory, convergent, divergent plate boundaries and the features associated, here are the examples that we discuss. Please note them down. Firstly, let us talk about divergence. For divergence, there are certain stages. For that, you can remember the East African Rift Valley. So, let us remember the the plate tectonic theory using examples. Okay. So, first comes your divergence. Okay. Note down, for ocean divergence, divergence, Atlantic Ocean can be considered. And what is the feature associated? See, if in your answer, whenever you are giving an example along with the feature associated, that adds some marks to you. Here the feature associated is mid-Atlantic ridge. Mid-Atlantic ridge, which is formed due to divergence. Then when it comes to continent-continent divergence, what is the best example that you can remember? Your East African Rift Valley. East African Rift Valley. The name itself suggests the feature associated with it, which is nothing but your Rift Valley. Rift Valley is the second stage of divergence. In the first stage, there would be faults or cracks. In the second stage, there would be Rift Valley. So, that is about divergence. And for ocean divergence, you can also remember Red Sea, because Red Sea is an example of linear sea. Red Sea is the one which is recently formed. Okay, please remember, in geography, recently means it is millions of years ago. So, that is the example that you can remember. Then, for convergence, if you ask me, for convergence happens in 3 different ways: ocean, continent and ocean-continent convergence. For ocean convergence, please remember this Mariana Trench, which is the world's deepest point, formed due to convergence between Philippine plate and Pacific plate. Okay. And then when it comes to continent convergence, you can simply remember India plate converging with Eurasia, leading to formation of Himalayas. As I told you, it is better if we actually mention the features associated. For ocean convergence, remember mentioning the trench and the volcanic mountains, all the island arcs that were present. Those are the features that were associated. When it comes to continent convergence, you can write the Himalayas, the fold mountain systems, which is a feature associated. Then when it comes to ocean-continent convergence, the best example is your Nazca plate interacting with the African plate. As I told you, the whole Earth's surface is actually divided into different plates, right? So, Nazca plate and South American plate are example for ocean-continent convergence. And what is the feature associated with ocean-continent convergence? it would be trench and a mountain arc or a volcanic mountain system. Okay. So, trench here is Peru-Chile Trench along the coastline of South America, and mountain system is your Andes mountain system. Okay. Then for transform plate boundaries, you can remember the North American plate associated with the John D. Fuca plate, which is a transform plate boundary. So, remembering plate tectonic theory would be easier if you take these examples into consideration. So, that is all about today's session. We will meet in the next video with another important topic. Thank you.